Okay guys, I want to give you just a little bit of help as you're analyzing the data from the flow rig. We went over in class all of the basics. I showed you a lot of mechanics, but there was two things that I want to show you also, because it hit me that this lab is really causing you to bring all the statistics information that we've talked about together. The individuals versus the average. So I just wanted to give you a heads up. So first of all, keep in mind what your objective is. What you're trying to do for each flow method, so the rotometer, the orifice plate, and direct capture, you can almost look at it. Each one is three different sets of data. Look at each one individually. What you're trying to decide is, in the future, when you go to use that, what can I expect out of that device? So your objective is to be able to tell me or to tell yourself, what can I expect from that device in terms of its bias? How far off is it from the average? And its variability. What kind of plus or minus accuracy can I expect? That's what you're trying to come up with. You're trying to answer that question, what can I expect out of you? You know, when we've been looking at data, that first question, that's what you're really trying to answer. Okay, so what I've got here is we looked in class, I've got my pivot table, and I've pulled down average difference of the rotometer, standard deviation difference of the rotometer, and the count of the rotometer. And so you see I've got my values here. I've already looked at all my data and I've decided that, so this is all of it. So I've decided it was consistent within the three measurements for each group. The groups themselves were consistent, so I averaged that. And then the days were consistent. So all the data has been put together. And so now what I did to save myself time is I came down here and I created this information right here. So first let me show you how I got it. Let me do that real quick. Let me go back up to the top. So the very first time I took all this, I copied it. I came down here, right there, that same spot, and I said paste special values. Okay, cool. And then I built the rest of this stuff around that. What that's going to allow me to do is, okay, now I want to go look at the orifice plate, or I want to look at percent difference. All I have to do is change my pivot table, and then I'm going to be able to come down here and paste this in, and everything else is going to stay. I don't have to redo that for every single piece of data, or the different cases that I want. So let me show you what I have. I have approximate flow. There's the average for each of those. There's S sub x, the standard deviation of the individual values. There's how many I have. There's the standard deviation of an average of 12. So what is that? That's this standard deviation divided by the square root of 12. And then now this is 3 times that for my error bars. Okay, so that's what I have there. And so then I created the graph, which, just like we said before, we created this. What am I graphing? If I click on this, you can see it's coming up here and it's graphing that right there. What's on the bottom here? It's this right here. What are my error bars? I don't think it'll highlight my error bars for me. It's this right here, just like we did before. So again, notice what that means is when I come down in and paste another set of data, all this, my graph's going to update. In fact, you can see I started this graph with the orifice plate, so now I have to come in and say, change the name to rotometer. Very nice. And before I forget to show you, once I get a graph and, oh yeah, this is what I want, then what I do is I take it and I say copy, and then move over to the side and paste that graph as a picture. So paste, bammo, paste it as a picture. So you can see down here, that's what I've done. There's my rotometer with the difference, my rotometer percent difference. There's my percent difference orifice plate. All these, you see I double click on them, nothing happens. They're pictures. That's just going to save you time when you go to do all this. Okay, so that's one thing I wanted to show you. Just mechanically, you set it up like this, and then there's everything you want. If you wanted to save these averages and stuff with it, you would have taken that and pasted it as a picture somewhere else. So that way you've got it for your lab report or whatever else you want. But you don't have to do all this every time just to, when you have multiple things like the orifice, et cetera, et cetera. Okay, so now here's one thing I want you to see. What I have on my graph now is I have the difference at each of the flow rates. What am I trying to do? I'm trying to decide what can I expect out of the rotometer. Well, my first question is the difference here different from here? Is the difference here different from here? I mean, obviously we see it going up on the graph, but now look at it with the error bars on it. When I look at how much variation I had within each of these points, I can't say that the difference between here and here is anything but random. If I had an average, if this was my population, what it was doing right here, randomly, I would expect that average to be anywhere between here and here. Well, this average is easily in there. And look at this average. I mean, it's barely above the top on this one. But when you look, this average could have been anywhere in here. So just by eyeballing these, remember I told you, if they're close, we're going to have one more tool. You don't have that tool yet, so you just use your eyeball on this. But when I look at this, I think all three of those are the same. So what can I expect out of the rotometer? Is this data set different from this? No. Is this data set different from this? No. You remember what we said in the overview, 3 questions. The second question is data A different from data B? If the answer is no, we combined it, and then we summarize it just like we did before. Okay, now here's what I want you to see. When we're making that decision, we're comparing averages. What can I expect out of that average? We're using the standard deviation of the average. We're not using this standard deviation alone. We're dividing it by the square root of that to get the standard deviation of the averages. Do you see that? Is this average different from this? My error bars, the thing I'm using to make that decision is the standard deviation of averages. Okay, now I look at these and I say, you know what? These are all the same. So what I'm going to do is I'm going to come down here and I'm going to average all 3 of these. So what can I expect from the rotometer? Average of these 3, I can expect a difference of about 0.05. That's what I can expect out of it. Now, how much variation would I see in that? Okay, now I'm talking about an individual reading. If you go use the rotometer and you just take a reading, what kind of variation can you expect? Then it's 0.04. Okay, do you see that? So what I would say to you is, what can I expect of the rotometer? I would expect a bias of about 0.05, and it varied by about 0.04 from that. Okay, now, this is where you got to think some. It's the real world. Things aren't always pretty. What we're used to doing is somebody telling us, okay, we can expect an average of plus or minus this. Well, you see, in our case, what this experiment is telling us is our rotometer is not calibrated. We're off by 0.05. So one thing you could do is you could make a note and you could tell yourself, okay, anytime you use the rotometer, take your number and adjust it by 0.05. Adjust it down because we're high. We have a bias high of 0.05. So when you take a reading, subtract 0.05 from it. Now we've zeroed. Okay, well, how much can I expect to vary from that? You can expect to vary plus or minus 0.04 gallons a minute. Does that make sense? Do you see how I'm using the numbers to give me an idea what to expect? Because over here, I created Okay, 0.05 plus 3 times that and 3 minus that. That's what this is. That's the confidence interval on individual values. Because you're asking me, what can you expect from a reading on the rotometer? We're not talking averages anymore. We're talking about a reading. Okay, I could expect it to go from here to here. Well, I mean, that's really hard for me to say, oh, I can't tell you plus or minus this. But since we've seen it's consistent, I could tell myself, hey, look, we're always about 0.05 high. Subtract 0.5 from that, and then the variation around that is about 0.04 gallons a minute. So you multiply that by 3. So I could expect, if I zeroed it by subtracting 0.05, I could expect a variation of about 0.11 gallons a minute, plus or minus. That's what I could expect for my accuracy. Okay, do you see that? The big thing to see is, number one, when you're comparing averages, you need to use the standard deviation of the averages. When you're worried about an individual reading, you need to use this standard deviation. Now, what if you were to say to me, you know what, the way I'm going to use the rotometer is I am always going to take 4 readings and average them. Then I would say, okay, and you're asking me, well, what could I expect? Well, you could expect that average. What kind of variation? Well, you would calculate the standard deviation of an average of 5. So you would change this to 5, get the average, and you would use that instead of those numbers. You see, it matters if you're talking about an individual or if you're talking about an average. The amount of variation that you would see in there is going to be different. For your experiment, I would keep it right now, use the average for comparing what mattered, and then report what you can expect for an individual reading from that device, because that's typically how people report it. What can I expect from an individual reading? I find it a little interesting. If you look at the spec sheet for the rotometer, it says that it's plus or minus 2% of full scale. Well, full scale is 5 gallons a minute, so 5 times 0.02 is 0.16 or 0.1 gallons a minute. And you look at what we said, 0.11. If we were to center this guy, then the amount that we were varying, plus or minus, was 0.11 gallons a minute. So we're right in line with what the manufacturer said we should be able to see for that. Okay, so hopefully that helps you sort out individual average, group average. Now, with only having 3 points, yours may come out a little bit different than this, and you'll have to work through that. If you find it easier to use all of the data instead of just your 3 points, feel free to do that with your analysis. Together, we've already looked at it, and we know that it's consistent across all the different people, all the different groups. So, you have the working collection sheet with everyone's data. Feel free to use that to make your final conclusions in your write-up for your memo, and because you have all that information. And so from a practical standpoint, really wanting to know what can I expect out of the rotometer when I use it, all the data gives us the best information because we have a lot more estimates from the different people. Okay, so let me show you one last thing, just what I was talking about. Now let's say I'm ready to go on to the orifice plate. So I'm going to come here, get rid of these guys on my pivot table. And we've already seen, we know the percent difference for the orifice plate is what we want to look at. So I'm going to pull percent difference orifice down 3 times. And now I'm going to change the first one to average. Change the second one to standard deviation, not the population. And the last one to count. Nice. Now I'm going to get this guy, copy it. I'll move down so you can see. Whoops. Now I'm going to come right there and just say paste special, values, bammo, and there it is. It's all in there. I just need to take these formulas and paste them there where I didn't have any before. And you see I did this guy with the $sign so I could copy it. And now, lo and behold, my graph is already done. Only thing I got to do is double click on this guy and come right here and say percent difference. And come right here and change this to and now everything's the same. So you see how convenient that can be. Just before I did that, I would have wanted to save my rotometer graph, save this information right here so I could get to it later. But you see how convenient this is. And again, you'll have to look at it and decide, but when I look at this, I'm honestly a little torn. My first instinct is to say, there's no difference. You know, I look down here and, you know, this guy, but then I'm like, okay, well, wait a minute. There's obviously a huge difference in variance at that level. So at 1.25, I mean, I'm not comfortable saying there's no difference because there was a lot more variance at that difference. And like, if I look at these guys, you know, where would I expect an average? Remember, we're talking standard deviation of averages. I wouldn't expect one any bigger than this. Well, then I come down here and this one's a good bit bigger than that. But because this band is so wide, it looks like it fits in. So like I said, I'm a little torn. Here's what I'm going to do. I'm going to come down here and I'm going to take these guys. I'm going to say copy. And I'm going to come right here and I'm going to say paste special, values. Now I'm going to say paste special, formats. Because I want to remember those. That's why I did them as values. Then I'm going to come up, and this is where the pivot table is really, really handy. I want to come up here, and I want to get rid of 1.25 and see how much does it change things. So now I can do just like I've done. I can take this, copy it, bring it down here to my data, come right here, paste special, values. Now notice my grand total's up here because I didn't have as many that time, so I got to get rid of that. And now I can look. So I've gone from plus or minus 1% to plus or minus 1.17 and a standard deviation of 2 to 1. So, you know, again, now I say, okay, for me in the lab, what can I expect out of this device? Is that worth it, having to report 2 of them now, having to tell you, hey, at 1%, you can expect something a little bit different? I'm not sure if it is or not. I maybe just make a note for myself. But again, I just want you to see, one, that's the problem with the real world, is there aren't clear-cut answers a lot of times. It depends upon what you want to do with it. And, you know, in this case, you know, now again, I'm very comfortable. All of these are the same. They're not different. So I would be real comfortable saying, okay, my rotometer on the average reads about 1% low. So again, if I wanted to adjust all my readings up 1%, I could do that. What would you expect from that? I would expect a variation of about 1.13%. That's 3 times the standard deviation of the individual values. If I'm at 1.25, I expect something a little bit different. What would I expect? Well, you could do the same thing. Do your pivot table, just do that one, put these numbers in, and you could calculate the same thing for it. Okay, so I hope this helps you. I hope it brings you together. The concepts of individual versus average and the standard deviations and when you use which to compare. To answer that whole question, what can I expect out of you? Because that's what we're trying to get at, because we're trying to make a decision. And what the decision is, our objective, determines what we do with the data to answer that question. And I am going to put a handout in the student files of this workbench one, or I'm sorry, in the DOE analysis one, so that you have the key formulas that you need to go back and reference to. Thanks a lot, and hope this helps you.